Entanglement and superposition. Quantum concepts compared. Superposition. Definition: superposition is the principle that a particle can exist in multiple states simultaneously until it is measured or observed. For example, an electron in a superposition can be in multiple places at once, or spin in multiple directions. Example: a quantum, non-classical coin spinning in the air. While it's spinning, it's in a superposition of both heads and tails. Only when it lands and we check it does it settle on either heads or tails. Significance: superposition is fundamental to quantum computing, where quantum bits, qubits, can represent both 0 and 1 at the same time, vastly increasing computational power. In classical physics, the outcome of a coin toss, such as heads or tails, is determined by deterministic and probabilistic laws, rather than superposition. Deterministic laws. Deterministic laws in classical physics state that future events are determined by past events, following well-defined principles and equations. Example: if we know the initial conditions, e.g., the force and angle of the coin toss, we can predict the outcome with certainty, assuming no external disturbances. Probabilistic laws. They consider the inherent randomness in events, especially when precise initial conditions are unknown. They provide the likelihood of different outcomes. Example: when we toss a coin, classical probability tells us there's a 50% chance it will land heads and a 50% chance it will land tails. No superposition in classical physics. In classical physics, the coin is always in a definite state, either heads or tails, even if we don't know which one. The coin does not exist in a superposition of both states. Superposition is a quantum phenomenon where particles can exist in multiple states simultaneously. In classical physics, objects and events follow deterministic or probabilistic paths, but they are always in a definite state at any given time. So, when we flip a coin in the classical world, it's either heads or tails, never both at the same time. Entanglement. Entanglement is a phenomenon where two or more particles become linked, and the state of one particle instantly influences the state of the other, regardless of the distance between them. This connection remains even if the particles are light-years apart. Example: we have two entangled particles, A and B. If particle A's spin is measured and found to be up, particle B's spin will be instantly known to be down, even if particle B is on the other side of the universe. Entanglement is a key resource in quantum information science, enabling phenomena like quantum teleportation and secure quantum communication. Differences: superposition deals with a single particle existing in multiple states, while entanglement involves multiple particles whose states are interconnected. Measurement impact: measuring a particle in superposition collapses it into one definite state. Measuring one entangled particle instantly determines the state of the other, regardless of distance. Both superposition and entanglement challenge our classical understanding of reality and are pivotal in advancing technologies like quantum computing and cryptography.